right. There we go. Okay. Hey everyone, how's it going? So, I guess, ironically, during, I think, Astronomy Cast last week, I was saying that where I live on Vancouver Island, it's the Florida of Canada because we have very balmy weather compared to the rest of the country. And we got dumped on with snow, like more snow than I've ever seen. Now, I do live in the mountains. I do live at a bit of an altitude now. So, it was a hell of a thing. But yeah, I guess we got just shy of about 2 feet of snow over like a night. And, yeah, that was crazy. And now it's gotten cold, like not Canada cold, but cold for us, like -5 Celsius, which is, it's not right. It's not right. And it's supposed to get even colder. I think on Christmas, it's supposed to hit -12 here, which is, I've never experienced that level of cold here. I've been to other cities, Calgary, Toronto, and experienced colder than that, but I've never had -12 here on my Florida-like West Coast. So anyway, yeah, I guess I did it to myself, didn't I? I summoned nasty weather. So, all right. So, just another bit of warning. This is going to be the last episode for 2021. So I'm going to take next Monday off, the 27th, and then I'll be back the Monday after that. So, yeah. So that's what's going to happen. So, just take a couple of weeks off, and then I'll be back. Florida's on the East Coast, not the West. Yeah. Would you possibly consider using 4-inch wheels to deal with the snow when you break down and purchase your electric mountain bike? Yeah, I've been looking at some sweet mountain bikes. A buddy of mine is like a really good mountain bike rider, and he put the earworm in my ear, and I've been watching mountain bike like YouTube videos, and like the bike that I want is just ludicrously expensive. So, but I suspect I'll be picking up an electric bike. I don't think I'm gonna get like a fat tire one. Because we just don't get that much snow. Like we'll have a couple of days of snow every couple of years, or tons of snow this year. But most of the time, no, we don't. Fat tires are not really that useful. Will I host a live event for James Webb? I don't think so. I think I'm gonna just watch it with everybody. Yeah, I don't think so. I've done like live stream events like that in the past, and it's like if you just like watch and do like a commentary stream, I don't know, it's not that interesting. Like the one that we did one time that was amazing was we did a live stream for the Curiosity landing, and we brought in tons and tons of guests who were involved with the missions, who were like just heroes of space exploration. And so we were keeping an eye on the mission, but then we were also talking to people, and it was amazing, and it was a lot of fun. And it just, just took an enormous amount of production help. And it's Christmas, so like nobody's going to be around. Nobody's going to want to do this kind of thing. So anyway, Cosmic Quest might be doing something live. Pamela sort of had the same opinion as me, so I'm not sure if she's planning on doing anything. But the last I talked to her, like during Astronomy Cast, she said no, thank you. All right, let's get into the show. So again, I've got a few questions ahead of time, and then we'll move on to the actual live show. So start kicking in your questions, and we'll get at them in a bit. All right. So recording reminder. Yes, Chad. And record the audio. Okay. Yes, I am recording. Okay, all right. Hi, everyone. Welcome to the question show, the last question show of 2021. There's going to be a break after this episode, just a 1 week break, and then I'll be back in 2022 with more of these questions. So as always, if a question pops in your brain, just write it down. I'll gather it up and I will answer them here. And of course, I do these shows live mostly every Monday at 5 p.m. Pacific Standard Time. So if you want to, actually it's Pacific Daylight Time. So anyway, I do these shows live every Monday on 5 p.m. Pacific Daylight Time. Anyway, all right. So if you want to join us live, come join the show 5 p.m. Pacific on Mondays. Chad's just going to cut that whole thing out. Anyway, all right. Let's get into the questions. I'm going to do the whole thing again. All right, here we go. Hey everyone, welcome to the question show, the last question show of 2021. I hope you had a good year. Here's to an exciting next year. I'm going to be taking 1 week off, so there'll be a 1 week break, and then we'll be back into 2022 with new question shows. As always, I do these shows every Monday, 5 p.m. Pacific, so if you want to join live, you can. There should be an announcement for the next one somewhere on the channel. But if a question pops in your brain, just write it down. I'll gather them up, and I'll answer them here. All right, let's get into the questions. Yeah, Chad would not like to try and edit that. Okay. Coach Adam, how can Starship go to the moon or Mars without a proper landing pad? The Regolith would be forced back up into the engines upon landing and takeoff and risk catastrophic damage. Is there thought being given to this problem? That is a great question. And most people this hasn't really occurred to them, that the regolith on the surface of the moon is incredibly dangerous for the spacecraft. And so when you think about, say, the Apollo missions, you had the Apollo missions, you had the landing module, and then you had the ascent module that was sitting on top of the landing module. And so the landing module would come down, it would fire its rocket, it would kick up a whole pile of regolith, and then it would land. Then the astronauts would get out, and they would do their science on the surface of the moon, and then they get back into the ascent module, and then they would kick off. And so the ascent module had never had its rocket connected or at risk from the regolith that's being kicked up from the surface of the moon. And this stuff is very damaging. And so there's some really interesting research that's been coming out from, say, Phil Metzger. I did an interview with him a couple of years ago about this, that when rockets land on the moon, they kick up this regolith. And in the low gravity of the moon, this stuff goes into orbit and lasts in orbit for a while. And so any spacecraft that's going to attempt to land after, say, a spacecraft has already just landed is going to have to go through this quite damaging stream of particles that have been kicked up to space. And there's going to be a limit to how many spacecraft can actually land until it just becomes too dangerous. Now, I'm not entirely sure how much damage, say, if Starship is landing on its thrusters and as it gets closer and closer to the regolith, it's going to do more damage, or if the regolith is just going to get blown away. But having a landing pad on the surface of the moon is going to be vital. And there's been some great ideas. One idea, of course, is just like the first spacecraft that goes, you then build a landing pad out of lunar material, out of lunar regolith. You just build concrete out of the lunar regolith. There's lots of ideas have been tested out here on Earth, and they should work on the moon. Just you'd have to take a machine to go and actually build the landing pad. The other idea is that you have a material, like a spray, that is held by the lander. And as the lander is approaching the surface of the moon, this material sprays down and coats the regolith on the moon and hardens it. And then the propellant and the heat from the propellant sort of instantly bakes a landing pad underneath the lander as it lands on the moon. And so you would minimize, you give yourself a nice firm landing, you'd minimize the amount of regolith that you're kicking up into space. But for long-term visiting to the moon, we're going to need like landing pads. All right. Bob Driscoll. Is it possible to have two planets of nearly equal size orbiting each other so that they also orbit a star similar to the way the Earth and the Moon orbit the Sun? Yeah, absolutely. So we don't have any of these. Sort of imagine two Earth-sized worlds orbiting around each other as they're orbiting their star, but it is theoretically possible. And the closest thing we have to a double planet here in the solar system is Pluto and its moon Charon. And so when you think about Pluto and Charon, well, okay, so when you think about any planet and its moons, the moons aren't orbiting the planet. What's actually happening is that the moon and the planet are orbiting a common center of gravity between the two of them. Now, the common for the Earth and the moon, the common center of gravity happens to be inside the Earth. And so it looks like the moon is orbiting around the Earth. But when you go to Pluto and Charon, that common center where they're orbiting around is actually outside of Pluto's surface. So they're sort of orbiting around this point in space. And you can imagine where the two planets are more evenly balanced. You've got two planets orbiting around each other as they're orbiting around the star. Now, I don't really know how stable that configuration would be if you had a lot of other planets in the solar system. Like, we know that Jupiter is quite a bully gravitationally and is always trying to kick the other planets around, and who knows what kind of mayhem it's done in the past. And I wonder if Jupiter being relatively close to, say, two Earths, a binary planet Earth, it would let that stand. And it wouldn't just break them apart, cause them to smash into each other or something. And that's why Pluto, which is so far away from anything else, has this stable configuration. But we see double objects all the time. We see asteroids with moons. We see Pluto, dwarf planet with another moon that might as well be another dwarf planet. We see double stars. So theoretically, yeah. And you can imagine some of the implications of that. Like, you would have, like, the planet would have regular, depending on how far away apart they are, but the planet would be having regular eclipses. The planet would be having regular eclipses of one another, which would be really weird depending on how they're lined up orbitally. But for an alien civilization, like if we were living on a planet Earth and there was another planet, it would be relatively easy to go and visit it, especially if it had a thick atmosphere. Like, the moon was really tricky to go to, partly just because there's no atmosphere, and so there's no easy way to land on the moon without a propulsion system. But if there was like another planet Earth, you could just fly to this other planet, and then you could go into the atmosphere and descend and land and visit with the locals. So it's a great idea. Obviously, it's a great science fiction idea, and I can't wait for someone to find one of these for real somewhere in the universe. Okay. Andrew D. There's not much certainty coming from this conversation. I wonder if it's even possible to come up with unquestionable results. Now, this question came from an interview that I was doing with Andrea Lynn about using a planet hunting technique to find planets around other stars. But it's a great comment, and I tagged it as a question, even though it was really sort of a comment, but that I think one of the things that we need to be really comfortable with as fans of space and astronomy is this world of uncertainty. And I think as you learn more about the universe, as you learn more about the way the telescopes, the techniques, the scientists, the missions, what everybody's doing to try and find stuff out there in space, you really are starting to see how difficult it is, how slowly nature gives up its secrets, and what is going to be the way forward, step by step, incrementally. And and it's funny because, like, maybe 10 years ago, I thought, okay, we're going to find Earth 2.0 any day now. And maybe the Kepler mission was going to be the one that would have found it. But now, as I see things like, say, the possible discovery of the chemicals of life on Venus, and then how difficult scientists are having to try and confirm this, I sort of think about how difficult it's going to be to find a planet just orbiting another star, like a sun-like star, at the same distance as the Earth does, in the habitable zone of that star, to scan the atmosphere of that planet and unambiguously know that there is some kind of chemical there that is evidence that there's life on that planet. It's going to be really hard. And even though we've got really powerful new telescopes, James Webb is going to be coming online. We've got the extremely large telescope. We've got these incredible new instruments that are all coming online. This search for life, this search for other planets is going to be difficult, and it's going to take a long time. And even when astronomers say, okay, we found one, others are going to overturn their results and go, no, you didn't. And so I would be amazed if we find conclusive evidence that there are habitable planets outside of the solar system in my lifetime, which I know sounds crazy, but I've been doing this job now for closing in on a quarter century, and I'm starting to get a sense of just how long things take. So, but I'm in it. I'm in it for the journey, and I'm really enjoying each discovery that gets made and putting them all into context. But I'm also managing my expectations about what we're going to find and how long it's going to take. So, yeah. All right, so those were the prepared questions, and so now let's get into the live show. James Moore, happy holidays. Can a black hole absorb... Let me do this again. James Moore, happy holidays. Can a black hole absorb dark matter? In theory, sure. It all depends on what dark matter is, but the main assumption that astronomers have is that dark matter is a particle of some type. And anything that goes into a black hole stays inside of a black hole. The tricky thing about dark matter is that astronomers think that dark matter, even though it's some kind of particle, it doesn't interact with regular matter or itself very easily. And so when you have regular matter, say you've got gas and dust that's swirling around this black hole, this gas and dust is bonking into each other and slowing itself down. It forms this big accretion disk, and then this accretion disk spirals in and goes into the black hole because this material can kind of collide with itself and apply friction across the entire process, and that's what helps drag that material inside the black hole. But the thinking is that dark matter doesn't have any kind of cross section. It doesn't like two particles of dark matter could fly towards each other and essentially pass through each other or get, I don't know, a Planck length apart and still not actually bounce off each other. And so you wouldn't get dark matter accreting around a black hole in the same way. Of course, one of the other theories is that dark matter is actually black holes, that there were black holes formed at the beginning of the universe, these primordial black holes. And so can a black hole absorb dark matter when that dark matter is a black hole? Yeah. Scott's Astrophotos. Will they redo the Hubble Deep Field with the James Webb Telescope? Absolutely. I've talked to some people, some researchers working with James Webb, and asked this exact question. Probably here on the channel a few times if you search for it. But yeah, so one of the plans eventually will be to do the James Webb version of the Hubble Deep Field. And so if you don't know what the Hubble Deep Field, of course, this was this time when they took the Hubble Space Telescope and they stared at a seemingly empty chunk of space for days. And over time, after all that data was gathered, they had this image, this very famous image that contained tons and tons of galaxies, that even a spot that seemed to have nothing in it actually contained tons of galaxies that were at varying distances from us until literally the beginning of the universe. And when Hubble wants to take an image of an object that's really far away, like 500 million years after the Big Bang, then it has to scan this single spot for a long time. Or it can use a gravitational microlens where there's some galaxy cluster in between Hubble and the distant object, and so this galaxy cluster acts like a natural lens to allow this object to be more visible. But James Webb is going to be so much more powerful, and so it's going to be able to do this stuff just it can look in any direction and see the first galaxies as they were forming in any direction that it wants. And it'll do it a lot more quickly than Hubble can. And so one of the plans eventually will be this James Webb version of the deep field, where they will stare at a seemingly empty part of space and try to see what they can see. And what they're expecting to see is this time at the universe just a few 100 million years after the Big Bang, when the first galaxies were coming together, when small dwarf galaxies were merging together to form larger galaxies. And that should give us a much better sense of how the early universe came together. Late Night Gamers asking, will Luvar be able to see all the way to the start of the first photons in the universe? Actually, did you grab that one, Nancy? Wormblood, do you still play RPGs? Or you mentioned writing something for Shadowrun. Would you consider streaming a small Shadowrun adventure? I haven't played any role-playing games in probably 5 years, maybe. Actually, so I used to play Ars Magica with Chad, and then a couple of other people here in the city that I live in. And I've also run some D&D games for my kids. And I'm thinking, like, my daughter is going to be back in town from college this summer. And so I'm hoping to run a campaign for her, my son, their significant others, hopefully. So hopefully this summer. Yeah, it's funny. Like, when the live streaming thing was coming online, I was trying to organize like celebrity game masters running games with like really great, the best game masters in the world running games live. And I was too busy and didn't get it organized. Had a bunch of people agree that they would do it, and I just never sort of pulled it together. This was like 2012, and that was like before this live D&D revolution. So I would have been well positioned, but I just never got around to it. I have too many ideas, not enough time. Okay. Banana Ham. Have you guys already talked about the water found on Mars? I haven't yet here, but I talked about it on Astronomy Cast, and I talked about it on the weekly Space Hangout, but I just haven't talked about it here on this channel. And this is a really incredible discovery. I think it's one of the biggest discoveries of 2021, and so I'm treating it like a question. And that is that astronomers use the European ExoMars spacecraft to detect the presence of hydrogen and oxygen, essentially the constituents of water, at the bottom of the Valles Marineris Trench on Mars. And Valles Marineris is the biggest, deepest valley in the entire solar system, incredibly deep. And they think that there's upwards of 40% water by volume in this regolith at the bottom of this valley. And that's huge because this region is very close to the equator. Like, obviously we know there's water at Mars's north and south poles, but people want to explore near to the equator, and to find that amount of water is huge. And there's a lot of other benefits as well. Like, if you're going to go down and explore, or maybe even set up some kind of camp at the bottom of Valles Marineris, you're at the bottom of a much more much more atmosphere. And so you would have an easier time trying to pressurize your environment, your suits, etc. Also, the walls of the valley would help protect you from a lot of the radiation that's coming in on the sides. And so you'd have a reduced radiation load while you're spending your time outside. And water is incredible. And even if it's not water, even if it's some other oxygen, hydrogen compound, the fact that those two molecules, those two atoms are there in that regolith means that it can be extracted and turned into fuel and propellant and it's the same thing. So it can be turned into fuel and drinking water and breathable air and all kinds of other stuff. So it's a really exciting discovery, and I hope someone is able to confirm it. Thomas Anfang. Thomas Anfang. Is the Starship program just a modern-day version of NASA's space transportation system from the 1970s? What lessons have SpaceX learned from the economic failures of the space shuttle? It's funny, like, if you go back and look at the original space shuttle documents, the original plans that they were starting to put together back in, say, the 1960s and 70s, the space shuttle that we see today is very little similar to what they originally wanted to do. So the original plan was to have this giant carrier vehicle that looked sort of like the space shuttle's main fuel tank, but with wings. And then the actual orbiter spacecraft would sit on top of this. And then there maybe would have booster rockets as well. And then this thing would take off vertically, fly up to a certain point, then the main fuel tank would detach and fly back down and land on a runway, and then the orbiter would fly to space, maybe with a couple of boosters, which would detach, and then it would finish off its mission and return. And so the space shuttle, the original idea was to try to make a two-stage reusable rocket system. And of course, then more requirements were thrown on, and it may be that it was just never possible. And so they switched to having the orbital be reusable, the booster rockets be reusable, but the main fuel tank was disposed of with each launch. And so the thinking was there, the plan was there. And so now with Starship having a propulsive landing, like, that's the difference, is that Starship, which is based on the technology of the Falcon rockets, is that it has a propulsive landing system. And that required modern computers. There just wasn't enough computing power back in the 1970s, 1980s, 1990s to be able to handle the complexities of having a rocket land, move its engines to be able to have it land vertically again on the ground, or on a drone ship in the middle of the ocean that's rocking back and forth. So it's funny when you go back and look, and I highly recommend this. Like, if you go back and look at historical NASA documents, there's a ton of them. NASA has a whole website dedicated to its history. And you look at some of the older ideas back in the 1960s, 70s, 80s. Every great idea that's being thought of, tested today, is in those documents. They thought of all this stuff. It's just that some of the ideas were considered too complicated, too technical, too expensive, too risky, and so they didn't develop them any further. But so with Starship, things have come full circle. It's the dream, is to make a fully reusable two-stage rocket. And finally, maybe some company will pull this off. Okay. John Morano, could a powerful laser from lunar orbit melt the regolith? I don't think so. I think you'd want to be closer. It's a good idea, though. Matt Potter, with a binary Earth system, wouldn't you have to take a lot more fuel to get back to the other similarly sized planet? Wouldn't this be prohibitive to visiting it and getting back home? Absolutely. Yeah. I mean, gravity wells are for suckers, right? So, but if you but then they would be able to build a rocket on the others. Like, is it like they would be able to build a rocket? They'd be able to refuel a rocket. They'd be able to. So, but yeah, no, gravity wells are for suckers. Don't go to gravity wells. But, you know, obviously you'd want to visit. Brad Kilshaw. If the universe started with the Big Bang, isn't a big crunch the only possible ending? No. There's many possible endings to the Big Bang. We know that at some point, 13.8 billion years ago, all of the matter that we see in the observable universe was far more densely collected together. And then something caused this region of space to become less and less dense over time. For essentially, back in the beginning, all the material in the observable universe was compressed into an area that was, I don't know, small, a few centimeters across. I forget the exact number. And that's just the observable universe. I mean, the unobserved universe could go on for an infinite amount in all directions. And so it's just that the universe was more dense back at that time. And then some event kicked off this expansion that we see today. And back in, say, the I'm going to say it was the 80s. Anyway, astronomers set out to figure out what is the ultimate fate of the universe. And so what they did was they measured essentially the expansion rate of the universe and tried to figure out, is the universe slowing down over time? And so that's the big crunch. The universe is expanding, like it had this initial boost, and then everything is moving apart, and then it's slowing down, then eventually the mutual gravity of everything is going to pull it all back together, and you get this big crunch. But another possibility is that all the material in the universe is expanding away from each other, and it's expanding at just the right speed that at an infinite amount of time, it will slow to a halt. And the other possibility is that it's expanding so quickly that it's just not gravitationally bound. It's on its way, and there's no amount of time that you would have to wait. You could wait for it to fall back into itself. And what they found was the middle one, that the universe, essentially the shape of the universe is such that the expansion is going to end at an infinite amount of time with the universe just coming to a stop. But then, of course, at the end of the 1990s, of course, in 1998, astronomers discovered dark energy. And this was this weird, mysterious force that is accelerating the expansion of the universe. And so now all those other ideas are out, because now you've got this additional boost that is speeding up the expansion of the universe. And so the future of the universe that we see today, that the one that appears most likely, is that all the galaxy clusters in the universe are going to accelerate away from each other faster and faster and faster, fall over the cosmic horizon, and be gone forever. And only around the Milky Way, Andromeda, our local galaxies, we're locally gravitationally bound to them, will form one big, large galaxy, and then all the stars will die, and then all the black holes will die, and eventually it'll just be this cold, dead thing in the middle of emptiness, and it will cool down to the background temperature of the universe, and that's the heat death of the universe. Yeah. All right, I was going to keep going, but that's good. It's so sad. Okay. John Morano. I wonder if greenhouse gases that terraform Mars could also absorb solar radiation, so you get a two for protection. Right, so one of the ideas to terraform Mars, to make Mars more habitable and livable, is to put very powerful greenhouse gases into the atmosphere of Mars. The kinds of stuff that's been banned, like chlorofluorocarbons, that have been banned here on Earth because of the damage they're doing to the ozone layer, not to mention how bad of greenhouse gases they are. Take that stuff to Mars, build factories, pump it into the Martian atmosphere, and thicken the atmosphere and warm it up. And theoretically, within a few centuries, few thousand years, who knows, you would thicken up the atmosphere of Mars to the point that it would warm up, and then a lot of the carbon dioxide that's locked away, a lot of the gases, a lot of the water that's frozen would start to melt, and you would thicken the atmosphere more and more naturally. And yeah, if you thicken the atmosphere on Mars, you would provide more protection from radiation from space. But it's not great. Like, it's not as good as a great big magnetic field that is surrounding your planet, redirecting all of the particles to the poles so they don't damage you. But more atmosphere is more protection, but not the best protection. But yeah, it would be a twofer. Altipan, if dark matter doesn't exist, what will happen? It's pretty hard to make the case that dark matter doesn't exist at this point. Like, at this point, astronomers have detected dark matter in many different ways, using many different techniques, and have measured it very precisely. They can look, they do these gravitational lensing surveys of the entire universe. They essentially look at the universe and watch how light is warped and tweaked as it's traveling vast distances across the universe. And they're able to map out places of essentially invisible gravity, which is acting like a gravitational lens out there in the universe and showing that this hidden mass is there. They have been able to measure the rotation rate of galaxies. They're able to detect galaxies that have only dark matter. They've been able to detect galaxies that have no dark matter. And so to come at this point and say, yeah, but what if dark matter doesn't exist, is like, it's like, say you're driving down the road and your car's making a horrible banging sound and you don't know what it is. Like, it's just, it's making this knocking, banging sound from the engine, and your buddy's in the car with you. And you're like, God, I wonder what that sound is. Maybe it's my engine, maybe it's my brakes, maybe it's my transmission. And your buddy's like, what if there's nothing wrong with your car? But like, you're hearing the sound. And your buddy's like, what if there's no sound? What if you're not hearing anything? Like, it's there. There's not a good sound coming out of your car, and you need to take it to the mechanic and you need to figure it out. And that's the same thing as dark matter. Astronomers know it's there. They've done the measurements. They just don't know what it is. But like, that's the same process as you hearing a weird sound coming out of your car. You know it's there. You just don't know what it is yet. But that's the next step. And so astronomers are now trying to figure out what it is. So I can't imagine a scenario that it doesn't exist, because it's been so well mapped and calculated and observed. But what it could be is there's an enormous number of ideas for what it could be. And now it's just a matter of testing out these ideas one after the other, carefully, laboriously, until one is able to explain what dark matter is, and every observation that gets made seems to hold up, and it makes predictions about the universe that are then observed. Then that would be the point where we would start to know what dark matter is. Maybe I put something in your trunk. And A.V. Scott and Flower asks, is it a possibility that dark matter is really miscalculations or misinterpretations due to the lack of understanding of gravity? Yeah, so that's the other main idea about dark matter, is that dark matter is not an invisible particle, but it's actually that we just don't understand how gravity works at the large scale. And I don't want to go into the details, but essentially that idea has been ruled out. That if you have two galaxies, and one you can measure that there's no dark matter in it at all, and this other galaxy you can measure that there's lots of dark matter in it, or only dark matter, then it's really hard to explain why it's just that we don't understand gravity. If you've got one galaxy that is filled with stars and one that has no stars, and yet they seem to have the same amount of gravity, it's hard to explain that, going like, well, we just don't understand how gravity works. Like the thought was that if you had a galaxy and we understand how gravity works at certain scales within a galaxy, but at the larger scales, maybe gravity works differently. Maybe it tails off and doesn't pull in the same way. And that was a perfectly viable idea. And astronomers really tried to confirm that that was the case, and they couldn't. And in fact, they found plenty of data that told them that it's not. And back to the car analogy, right? You can imagine, like, you're driving on, your friend says, well, maybe something wrong with the headlights, and you flick on the headlights, you can see the headlights come on, and you're like, it's not the headlights. I've tried that. Astronomers have tried that. Nick Vigerfil. Okay. Nick Vigerfil. What makes the regolith of Mars and our moon different from the Earth's soil? Yeah, it's funny. We don't use the word soil or dirt or earth. We use the term regolith. And I guess I sort of got that, like, I used to use dirt and soil and earth and stuff as a term, and lots of scientifically minded people gave me a hard time about it. And so now I've gotten very careful about how I describe the crushed up rock that is found on the surface of the moon and Mars. And that's exactly what it is. So if you go and pick up a scoop of dirt on the moon, the regolith, and you examine it under a microscope, all you will see is tiny shards of smashed up lava rock. And that is meteorites have been bombarding the surface of the moon for billions of years and have just churned up the surface of the moon into this just small glassy material. And if you go to the Mars, it's a little more different because Mars has had water and wind in the past. If you go to Mars, it's a little different because Mars has wind and it has had water in the past, but it's also had its share of volcanoes and meteorites striking the surface and grinding it up as well. But again, if you look in a microscope at the Mars regolith, you're just going to see little rocks, sand. And the difference is here on Earth, when we talk about our soil, it is small rocks, but it's also organic material. You've got decayed leaves and, it's called humus. One is chickpeas and the other is decaying matter. But, so you've got sand and rock, but you've also got this organic material that's mixed in. And we need this organic material to grow plants here on Earth. Without that organic material, plants can't grow. And so you won't be able to grow anything in lunar regolith or Martian regolith until you get that organic material mixed in. You got to start composting. Watch The Martian to see how to grow potatoes on Mars. Okay. Nicholas Sauer, am I a mini worldser? I'm neither. I don't know enough. I know Sean Carroll really likes the many worlds hypothesis. We've talked about it in the past. I'm just a journalist, not a scientist, and so I don't have the knowledge to say. Matt Potter, does dark matter gravitationally bend light? Really? I didn't think it interacted with light in this way. Yeah, dark matter doesn't interact with regular matter through the like it doesn't heat matter up. It doesn't interact with its magnetic field, but it interacts with regular matter gravitationally. And light is pulled, can be affected by gravity. As light is moving through a gravity well, it gets bent. And yeah, so it's incredible. I mean, it's some of the most incredible science that's been done, where astronomers have used Hubble, for example, and they've observed these galaxy clusters, and they're able to map out the direction that the light is taking as it moves through just empty space. And they're able to use that to then map out where the dark matter, the clumps and blobs and shapes of dark matter in these regions. And it causes, and so it distorts. And so again, like we don't know what dark matter is, but we know how to use it as a telescope. It's amazing. Marco Cambray, I'm wondering if aliens can detect our satellites from far away. Probably not. I mean, they're small. I mean, we can barely detect satellites. Even the Hubble Space Telescope couldn't detect the lunar lander on the moon right now. And the moon is close compared to light years away. Christopher, does the search for habitable exoplanets ignore the possibility of gas giants with habitable moons? Are there future prospects for seeing large exomoons with enough resolution to learn their mass, etc.? I did a great interview with Dr. Alex Tichy here on my channel, all about the search for exomoons and what that means for life. And could you have gas giants orbiting around, or having Earth-sized worlds orbiting around gas giants, and how would we find them, and so on. So I'll put a link to the interview and you can check that out. It was great. It'll answer all your questions about exomoons. Irish, what generates a magnetic field? Moving electrons. Jack D42, when a supernova explodes, do the elements come out molecular sized or big as chunks? I actually don't know the answer to this question. Like, obviously you get, because like we have blobs, we have veins of gold and things like that here on Earth. And so when the supernova exploded, or when the two neutron stars collided with each other, was it just individual particles that then collected under mutual gravity, or did you actually get blobs? I don't know the answer to that. It's interesting. I like the question, but I don't know the answer. I'm sorry. Typically, I go to Twitter and ask all the people there. Morpheus Dream. Hey, Fraser, after James Webb, what missions should we be looking forward to? I mean, there's so many. I would say, I mean, not necessarily missions, but the big stuff that you're going to want to watch in 2022, we should see first light for the Vera Rubin Observatory. This previously was known as the Large Synoptic Survey Telescope. And I think this is like my favorite telescope idea. It's going to be scanning the entire night sky from the southern hemisphere every 3 days, and it's going to be looking for anything that changes. So it's going to find asteroids and comets. It's going to find Planet 9. It's going to see supernovae. It's going to see variable stars. It's going to it's going to find things that we didn't even know we were looking for. Anything that changes, it theoretically is going to be able to find planets. So anything that changes in the night sky, Vera Rubin is going to be the machine that finds it. I would say that's the thing in 2022 that I'm most excited about. But we should see the first launch of the Space Launch System. We'll see. Looks like they're going to have another delay. We should see the flight of Starship to orbit in 2022. And then sort of around the corner, we've got the Titan Dragonfly, which is going to be sending a nuclear-powered helicopter to fly around the skies on Titan. We're going to see the Europa Clipper, a mission sent specifically to search for the geysers and try to analyze the potential geysers on Europa. We're going to see the Europeans' JUICE mission, which is going to be visiting the other icy moons, including Enceladus. It's going to visit Ganymede and Callisto and Europa, and mostly studying Ganymede, which is one of the most exciting places in the solar system. There's like too many missions to mention. By 2026, we should be getting the extremely large telescope, which is going to be a 39-meter telescope, which is just going to be a mind-bendingly large telescope. It should be capable of observing Earth-sized worlds orbiting sun-like stars, like directly. Like you'll just take a picture and go, "There's another Earth." So I've been waiting a long time for a lot of these missions, and now here we are, 2021. A lot of these are just a couple of years away. The Late Night Gamer. Could a black hole be survivable with solar systems inside perfectly safe? Probably not. But it depends on the size of the black hole. So we know that when you have some compact object, I mean, just Earth is a good example, right? The Earth is an object with gravity. And if an object gets too close to the Earth, it enters what's called the Roche limit. And that's a region where essentially the gravity pulling on the front side of this object is different, so different from the gravity pulling on the back side of this object that it gets torn apart. And then those pieces get torn apart, and they get torn apart. And so as a moon, say, got really close to the Earth, it would get torn apart and torn apart and torn apart and just go into orbit, and then it would crash down onto the surface of the moon. And the same thing would happen around a black hole. If you got too close to a black hole, the gravity pulling on your feet would be stronger than the gravity pulling on your head, and you'd be pulled in half. And then the gravity pulling on your feet would be stronger than the gravity pulling on your torso, and then that would be pulled in half. And so you would just be turned into this stream of particles as you would go into the black hole. And that would suck for you, and it would suck for the planet you lived on. Obviously, the planet would just be smeared out and turned into, like, a solar system could not survive. But if a black hole is bigger, then the event horizon is smoother, and the tidal forces on you are less and less extreme. And so for a stellar mass black hole, if you got really close, yeah, you get torn apart. But if you had a supermassive black hole, something, say, the size of the one at the heart of the Milky Way, then you could pass in through the event horizon of that black hole and not really know that you were experiencing these tidal forces. But as you got closer and closer to the center, you would. And that's where you're going. You're inevitably heading towards the center of the black hole. And so if you had like some of the most powerful, some of the most massive black holes in the entire universe, ones that are billions of times the mass of the sun, then you can imagine a planet passing into the event horizon and orbiting around inside this event horizon and not being torn apart. But there's going to be tons of radiation and other forces, gravitational forces and stuff that are going to be acting on it. And so that would probably still make it for a bad day. But if you could stay outside the black hole, they actually serve very useful things. One of the coolest ideas that I've ever seen, like a place to have the most population possible, would be you would have like a supermassive black hole, and then you would have smaller black holes orbiting around that supermassive black hole, and then you would have planetary systems orbiting around those black holes, and it would be gigantic and stable, and you could eventually come up with a star system, a solar system with tens of thousands of planets all orbiting black holes and relatively close to each other in perfect stability for a long period of time. And maybe that's what some future civilization will do. But no, you don't want to park your home inside a black hole. All right, let's wrap this up. So I'm going to read the patrons and the outro, and then I'm probably going to have to wrap it up at that point. All right. Pamela, answer some quick questions. Who can say? All right. More questions in a second, but first I'd like to thank our patrons: Gary Golden, Marcel Jan Krigsman, Philip Shane, Joe McTee, Jonathan Slocum, and the rest of our 791 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. All right. Well, those are all the questions that I had this week. I wish all of you a happy, safe holidays, and I look forward to seeing you again in 2022. All right. We'll see you next year. And the outro. If you want a single comprehensive resource for space news, you want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano. All right. I'll stop the recording. Stop that. Save it. Second. All right. Okay. All right. Take some quick questions here. TB Seeker, what would happen if two black holes combined? They just make a bigger black hole. It's like, what if you put two spiders in a jar? You end up with one fat spider. Black holes show little flags like golf course. Someone write that black hole system book. Yeah, if you do a search for like the most planets in a solar system. Let's see if I can find it. We wrote about it. Most possible planets. I wish I could find it again. It was awesome. Yeah, we don't have it. We wrote about it on Universe Today. I'll if I can find it. Corvair win. Lesson. Go head first. Yeah. Yeah. Nick Vigor fell. So we can mix organic material with lunar regolith to make soil. Yes. Yeah. So if you poop into the regolith, then if you add compost to the regolith, then and people have done these experiments. They've actually been able to grow stuff on Earth. So yeah, theoretically. Arjun, are there any concerted efforts to analyze old sky data? Yeah, well, I don't know about concerted efforts, but we report on a lot of stories about people going back and finding, like, they find something interesting and they go back into old data and go, oh, this star wasn't there in 1936. So those old data are still very useful to people. RJQ, any idea on how Hawking radiation could be observed? It's very slow. Like every few million years, one particle is released. But in the end, when a black hole is almost fully evaporated, then the heat rises, the amount of particles that are coming out of it go faster and faster, and eventually it explodes in a blast of gamma radiation right at the very end. And so you should be able to see these blasts of gamma radiation as black holes die. And astronomers have looked for this. They haven't found any, but in theory, they will. MC, what is the effect of cosmic rays on the Earth? Not much. You are being hit by cosmic rays every now and then, and they blast apart your DNA, and then your body repairs it. In worst case, you can get cancer from this. You know, some of the effects of cancer here that people experience are from cosmic rays hitting them, but the Earth's magnetic field and the atmosphere protects us from most of it. But if you're out in space, it's another story without this protection. All right, I should roll. Gotta make dinner, but thank you everyone for joining me today. Super fun. Thanks to all the mods. Thanks to Nancy, of course, for riding shotgun and helping out. I really appreciate it. I hope all of you have a wonderful holiday, and I will see you in some capacity in 2022 after James Webb launches. All right. Thanks, everyone. We'll see you next year.